Hi everyone, let's consider y or f of x equals the fraction x minus 2 over x squared minus 4x plus 4. Some people may observe that 2 is a 0 of both the top and the bottom. And what does that mean? 2 is a 0 of both the top and the bottom. So that means that x minus 2 is a factor of both the numerator and the denominator. Now, you don't have to observe that this early on, but I just wanted to make that comment that since 2 is a 0 of the top and the bottom, it's a common real 0. That means that x minus 2 is a common factor for both the top and the bottom. Again, you don't have to observe that now. You can factor the bottom, and you'll see this happen. How do you factor x squared minus 4x plus 4? Again, this is a hint. This turns out to be a PST. It didn't have to be, but this does turn out to be a PST. It is, in fact, the square of x minus 2. So when you factor, you get this, x minus 2 over the square of x minus 2. This is clearly not simplified because x minus 2 is a common factor in x on the top and the bottom. So what can we do? We can cancel out or divide out a pair of x minus 2's. We have one x minus 2 factor on top. That's a way of looking at it. We have one x minus 2 factor on the top in the numerator, and we have two x minus 2 factors on the bottom in the denominator. So one factor up here can cancel out with one factor down there. And when we simplify, we still have one of these x minus 2 factors surviving down below. So I want to note that algebraically, this expression here is perfectly equivalent to this expression over here. There are no hidden restrictions. There's an evident restriction right here. We know x cannot be 2. This is an evident restriction. Evidently, x is not allowed to be 2 because that would make the denominator equal to 0 in the simplified expression over here. It's evident. So it's evidently a problem when x is approaching 2. That means we're going to get a big explosion, and that means we're going to get a VA. Okay, now here's the deal. Because we have a graph for a rational function, at x equals 2, there are three possibilities. We're either going to get a point on the graph, or a hole, or a VA. So at x equals 2, we're either going to get a point on the graph, or a hole, or a VA. But wait a minute, I know that we're not going to get a point on the graph. Why not? 2 is not in the what of the function. It's not the domain, because it makes a denominator equal to 0. So right here, because 2 is not in the domain of f, 2 is not in dom of f, that means that we cannot have a point on the graph. 2 is not the domain of the function. We're not allowed to have a point on the graph of f. Now, why don't we have a hole? Why don't we have a hole? And why is it that we have a VA? Because the corresponding factor x minus 2 ends up surviving. The problem factor, as x approaches 2, is x minus 2. See, if x is approaching 2, the problem is that that bottom is going to be approaching 0, and that's a potential problem, right? And this factor survives. In the simplified expression, after you do your cancellations, in the simplified expression, an x minus 2 factor survives in the denominator. So it's still a problem. And we're going to get a huge explosion. And that leads to a VA. So as x approaches 2, this x minus 2 factor up here, this robot, it valiantly tried to save us from a big old explosion, but it failed. We needed 2 or more robots. We only had 1. We had these 2 bombs over here. One robot did knock out one of the bombs, but we still have that second bomb that survived down here. As x approaches 2, that bottom is still approaching 0, which means we're going to get a huge explosion. If the top is a number, is a non-zero number or approaches a non-zero number, and the bomb's approaching 0, if the top is approaching a non-zero number, if the top is approaching a non-zero number and the bottom is approaching 0, we have a problem. We have a problem. We're going to get a big old VA on this rational graph. So that's why we have a VA and not a hole, because the problem factor, the x minus 2 factor, still survives there after we simplify and cancel. So because of this, we have a VA and not a hole. For the graph of a rational function, you cannot have both a hole and a VA. In general, you can. I mean, you can have a messed up graph like this. Actually, it would be more like an open endpoint, I guess. It would be more like an open endpoint. But there's more of an open endpoint. We could have something like that for a function. The thing is, though, a guy like this would not be rational. Right. For a rational graph, you can only have one of these at x equals a given real number, either a point on the graph or a hole or a VA. It's one of these 3. If you don't have a rational graph, you could have various things going on.